All right, now we're going to work the example in the notes together. It says a 2-kilogram ball is moving at a velocity of 5 meters per second. It collides with a stationary ball also of mass 2 kilograms. After the collision, the first ball moves off in a direction 30 degrees to the left of its original direction. The second ball moves off in a direction 90 degrees to the right of ball A's final direction. What is the momentum of each ball after collision and the speed? Okay. Now, that's a lot. Sounds like a really, really long problem. So what we're going to do is when we do our solution, what we're going to do is we're going to chunk it and we're going to read each thing step by step. So first of all, we're going to write our given. And it says that both balls are 2 kilograms, so MA is equal to 2 kilograms, and MB is equal to 2 kilograms. And it says that ball A is originally moving at 5 meters per second, and ball B is at rest, so that means the velocity is 0. So it says find the momentum of each ball after the collision, which would be PA prime and PB prime, and then their respective velocities, VA prime and VB prime. Okay? All right, now the first thing that we're going to do is we're going to draw a picture of what's happening. Okay? If you don't have a picture, it's really difficult to do this. So I have ball A, and ball A is moving along with a certain velocity. So this arrow here represents the momentum of ball A before collision, and I'm going to call that PA prime. So then it hits ball B, which is stationary. So this vector, PA prime, that actually represents the total momentum before. So this is the total momentum before. Now, can I calculate? Oop, there's no prime here, it's just PA. So this is the total momentum before. So if I want to calculate this, the total momentum before, PA is equal to MAVA. Now remember, the total momentum before is the sum of A plus B, but B is stationary, so it's 0. So if I calculate this, this is 2 kilograms times 5 meters per second. So 2 times 5 is 10, and this is a kilogram meter per second. So the total momentum before is 10. Now, we need to have a frame of reference. So the frame of reference is going to be the original direction of ball A. So what I'm going to do is I'm just going to draw an imaginary line like this to show that's my frame of reference. It's kind of like the x-axis. So this is my frame of reference. Now I'm going to read the rest of the problem. After the collision, now remember the collision's like the equal sign. After the collision, the first ball moves off in a direction 30 degrees to the left of its original direction. So here's ball A's original direction. So this would be 30 degrees to the left. So this angle here is 30 degrees, and this vector represents PA prime. This is the momentum of ball A after collision. Then it says the second ball moves off in a direction 90 degrees to the right of ball A's final direction. So this is ball A's final direction. So 90 degrees, 30 plus 60 is 90. So here's ball B, and this angle here is 60, which means this angle here is 90. So this is the total momentum before, and these two added head to tail is the total momentum after. Okay? Now, where do I start? So after I get to this point, what I'm going to do is I'm going to draw my momentum triangle. So here is the total momentum before, this vector, which is PA plus PB. PB is 0, so it's just PA. From where I start, this is where I started, to where I end, I'm now going to take these two vectors and I'm going to add them head to tail. So this one here is 30 degrees up. So I'm now going to draw this 30 degrees up like this. This is PA prime. From the head of this vector, I'm going to do the tail of the other. So remember, it goes down like this. If you need to think about, go back to like geometry, okay, and think about alternate interior angles. See how these angles are the same, right? So remember, it's 60 degrees. So this angle here is 60 degrees, and this is my 90-degree angle. Now, do I know what this is? Yes, I know that the magnitude of this hypotenuse, I already found out, was 10 kilogram meters per second. So I have a right triangle, I know the hypotenuse, and I need to find the other two sides. This is PB prime. Can I do this? Absolutely. I learned this when I did geometry. So where should I start? Should I do, it doesn't matter. Probably the easiest way to do this is, because we're going to find the velocity, and what I found is it makes it a lot easier so you don't get confused. So what I'm going to do is I'm going to move this, and I'll do this so we can still see the triangle. And what we're going to do is we're going to separate this. So I'm going to say ball A, and I'm going to do ball B. Alright, so let's say I want to find PA prime. Do I use sine? Do I use cosine? Do I use tangent? It really doesn't matter. Just write one down. So if I'm using cosine, cosine is equal to adjacent over hypotenuse. So in this case, cosine theta, cosine of 30 degrees is equal to what's adjacent to it? PA prime over the hypotenuse, which is PA. Now, I know this, and I know this. The only thing I don't know is this. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So PA prime is equal to PA cosine of 30, which is equal to 10 times the cosine of 30. So PA prime ends up being 8.7 kilogram meters per second. Now I want to find the velocity. So the velocity is VA prime. So I'm going to first write down, what's my definition of momentum? Well, momentum is P is equal to mv. Now I'm going to apply the definition of momentum to find VA prime. So PA prime is equal to MA times VA prime. And I want to find VA. So I'm going to rearrange the equation and say that VA prime is equal to PA prime over MA. So it's 8.7 kilogram meters per second divided by 2. So VA prime ends up being 4.4. And that's it. Now we do the same thing with ball B. So should I use sine, cosine, and tangent? Well, an example, just to show you that you could use sine or cosine. So instead of using cosine, we'll use sine. So sine of 30 is equal to opposite over adjacent. Or I could do cosine again, because PB prime is opposite the 30-degree angle and adjacent to the 60-degree angle. So you use whichever one you're most comfortable with. So sine of 30 is opposite over adjacent, so it's PB prime over PA. So PB prime is equal to PA sine of 30 degrees, which is 10 kilogram meters per second times 0.5. So PB prime is equal to 5. Now I want to find VB prime. That's the velocity of ball B after collision. So again, definition is P is equal to mv. Momentum is mass times velocity. PB prime is equal to mb times VB prime. Now remember, you can use sine or cosine. sine of 30 is the same as cosine of 60, right? Okay. If I'm solving for PB prime, it's opposite the 30-degree angle because I use sine. If I did cosine of 60, it's the same as sine of 30, right? Okay. So you do it whatever way you want. If you want to use sine, you use sine. If you want to use cosine, you use cosine. Either way, you're going to get the same answer. You just have to use the correct angle. So PB prime is equal to MB VB prime. So VB prime is PB prime over MB, which is 5 divided by 2. So VB prime is equal to 2.5 meters per second. These types of problems can easily be done systematically, step by step. So if you just follow these steps, these are actually pretty simple. The hardest part is drawing your picture. Do you see that once you draw your picture, the problem kind of solves itself? So if you go back here, first you want to do a what's happening picture. So the total momentum before is equal to the total momentum after. Again, because these are vector quantities, we cannot add them algebraically, we have to add them vectorially. So the total momentum before is equal to the total momentum after, added head to tail. And that's it. That's how we do these types of problems.